d of, and d, is that d of x?
Yeah, that's basically the derivative.
Yeah, that's another way of writing like y prime, which they all mean derivative.
Equals 0. So d over dx means derivative?
Yeah.
Okay, all right, good, thank you. That means derivative. So the derivative of a constant, and that's what's in C, equals 0.
So a constant could be also like, I guess because x would be kind of confusing, like a number like -1, 2, 5, and like 55. It would all equal 0.
It always equals 0. The derivative of it is 0. Okay. So, all right.
Integer. Any integer number would always equal 0 in an equation when you're trying to find a derivative.
Okay. So now when you did your example, now will you walk me through the example?
Maybe try one without the x.
Yeah, I just put like find, I guess.
So am I supposed to write 0?
Yeah.
Okay, so the derivative is 0.
Yeah.
Hey, how are you? They're just teaching me for just a second. What can I do for you? Do you need help with your stuff? Derivative, of f of x equals 7. And I would tell you 0. Okay.
For any number.
Yeah, for any number.
Any number.
The power rule, which this is the.
Can I tell you this?
Notation.
This is the exact same stuff they taught me last year too. Power rule. The exponent. I think I got a 90 on my test. The exponent of the. So it's the exponent minus 1.
So you times the exponent by the coefficient and then subtract the exponent minus 1.
You would first you would times the exponent to in the front. So it'd be like that, like 3x.
Okay, so I gotta write this down. D over dx, x to n. If I do this, equals n x times n minus 1. Okie dokie. Okay, so example. So I would write this. I would write d over dx, and then in brackets I would write x cubed.
You don't have to write it like that. You can just say, if they said find the derivative of x to the third, you could just say 3x squared.
Right?
Yeah.
Yeah. Okay, I got that. Even on my own before I looked up.
So because those are your different notations on the side. You can write d over d of x. You can write y prime or f of x.
Okay, derivative.
They all mean derivative.
So d over dx, or see, I learned it that way. Why? That's how I learned derivatives when I took calculus. That's how things were wrong.
We use y prime normally, but we use all of them really.
And I never learned that the function way.
Really?
It's like kind of like y. Just
I know, but that's how you guys learn it even in middle school math. I was like, what the heck is that? We learned it a little bit differently. So that's why I never knew what are you doing this? And g of x and f of x. I'm like, what are you talking about? Okay, I'm good. Constant rule, power rule.
So what's the derivative of x to the 7th?
X to the 7th, okay? X to the 7th will be 6x to the 5th. No, 6x to the 6th. No, 7. Sorry. 7x to the 6th.
Yeah.
Okay. I was trying to do it without writing it. Okay.
Okay, the third rule will be constant multiple rule. This one's kind of it's kind of confusing, but once you it's kind of like the power rule.
It's like you have to actually do it to understand.
So with this one, you'll usually have to rewrite the problem, like in order to differentiate it.
Okay, will you write the rule for me?
Yeah.
Okay. There's supposed to be a bracket on the other side of that F.
Oh, yeah.
Okay, just wanted to make sure that it ended, okay? C. Is that a 1 next to the F?
Yeah,
It's the prime.
The one needs the,
Okay,
It's not a 1, it's like a prime
it's like a
symbol.
prime, like, that's the derivative.
it's not really any number.
It's not, it's just a symbol.
Yeah. Kind of.
Okay, so. I don't see what I'm doing. All right, I have no idea how to do this.
So at first you would rewrite it. And then, since this is a 1, right there, you do x over 1/3.
Okay.
And then after this, you use the power rule and you get 1/3.
Okay, so then it's like now,
And that's when
we use power rule. And I'm gonna do so.
Please pardon the interruption. They are going to be working on our network system, so everybody is going to be losing internet access within the next 10 minutes, and probably won't have it before you leave today. So
Let me just check
everybody's
something.
going to lose internet access within about 10 minutes.
1/3 x.
Corey Hitt, please call extension 1920. Corey Hitt, please call extension 1920.
2/3, right?
Yep.
And I can't have a negative exponent.
So then you'll simplify it, and the simplified version is like that.
Now, simplify. And that will give me, okay.
You basically just move the x to the
Yeah,
denominator.
basically, yeah. It's just,
So like you could draw that in parentheses.
Yeah, so that's my only thing. I don't know how to simplify
it's just like you
negative
move,
exponents, but I just don't
Yeah.
remember that. 1/3. Okay.
And then she moved the x and negative 2/3 to the bottom and rewrote it in fraction form.
like how kind of,
Yeah,
When you
but I
first
just
started.
did 1/3, and then I moved my numerator up to here, so that would be the cube root of x squared. Yeah, okay.
and that would be your final answer.
Okay.
Do you understand that like when you do it, you take the right number and multiply it by?
Yeah, I understand that. I mean, I don't remember that part of my algebra. You know what I mean? For the simplifying part. I can follow steps.
Okay.
But you know what I mean? I don't, when you just say simplify, it's like, I don't know the steps anymore.
Yeah.
I don't remember how to do that.
Okay.
Yeah, just remember that when there's like, you see a negative
Yeah,
like
just flip
that,
it.
just put it in the bottom.
And I have to also flip the exponents. It's the cube root.
Yeah.
Yeah.
You wanna do another problem?
Another one of these?
Yeah,
Or do I have another rule to learn?
there's
Yeah.
other 2 rules left, but.
Okay, tell me my 2 rules, cause I gotta go.
Mm-hmm.
So this is the sum and difference rule. And it's basically a combination of the power rule and the constant rule. This notation was really difficult, but when you actually do it, it's nice. And like once again, this just means the derivative of it. So the derivative of the f of x and derivative of g of x. And that's for the addition, and then when you subtract, those are like the actual notation.
So if I have two numbers or integers added together, the derivative is each other's derivatives added together. Is that basically what it's telling me?
Yeah, basically, yeah.
So, if you had 8x to the third plus 6x squared minus 5x plus 15.
Okay, so sorry.
And now you're basically just going to use the, you're going to use the product rule and the power rule and the constant. So you multiply these two together, and then you do your subtraction by 1. And here, this would just be 5 because there's an exponent here, and if you subtract, it becomes 0. So you have no x's left.
Okay. So this is going to be,
and here you have another constant, and it just becomes 0, so you don't even need to write it.
where'd you get -5?
Right here.
Oh, I thought that the whole thing would become so that 5 times 0 is 0.
No, because we're not multiplying anything.
Okay.
This is a constant. Whenever you
No,
have
no, I was
like
looking
that,
at
you
5.
get
She,
that.
yeah,
No,
she
I was
meant the,
looking at
the
5x.
X. She thought
I thought the x became 0, so that 0 times 5 would be 0.
Oh,
But that's
yeah.
not true.
no.
the
Just
X,
anything
X
to
by
the 0
itself,
power
yeah.
1.
X by itself is 0.
like X by
Or
itself, just like,
would
cause you know
be
how
zero.
you know how X squared is 2X, it's just 2X, cause you minus it, the 2 minus 1.
Yeah, so you just did 1 minus 1 right now.
Yeah.
So let me see here.
It would just go away, the X, when it's by itself, like that.
So like
24x squared
It would be considered like
Plus
1.
12
x to the 0 equals 1.
x to the 1 minus 5. Okay.
So if you have x to 0, it just equals 1. So then this becomes 1. If you did 5 times 1, then you just have 5.
That's why I don't know that I like the way then that rule was written. That's that constant rule is, the way it's written, equals 0.
This?
No, when you wrote me the constant 0, you wrote the derivative of a constant equals 0.
Yeah, like this 15 right here, this equals 0. I just didn't write it because you don't really
I
need
thought
to.
that was this one. Oh, okay, so that was that one, equals 0, okay. That's part of the power rule. Okay, I get it.
Yeah,
I get
so
it.
you're using the power rule when you
For the first
do
3
this.
things, we're using the first 3 things, use the power rule. Okay, that's it, I got it. These are all power rule,
Did you get this?
and this is the constant rule. Okay, I got it. Yep. I was applying the constant rule to the power rule. That's what I was doing wrong. You know?
Okay, and then another one would be 4x. Do you want to see if you can get that one?
I will.
Sorry if my handwriting's really bad on the board.
It's fine. We all have our favorites, right? I won't think you're funny. The product rule. Miss Forrester's favorite.
And this is the rule for it?
So Bishop asked us a question on the test since it's her favorite rule.
Yeah, for all of them. So this basically means when you're multiplying two things together, one term is going to be A, one term is going to be B. So you take the A, and then you would find the derivative of term B, and you multiply those together, and then you add this derivative of A to the B. And I can show an example.
I think you're sick if this is your favorite. There's something wrong with her.
Did you get the rule? Because I might do
I wrote it, yes.
Okay, so this is term A. This is term B.
Just a second.
And then remember you're doing A times B prime plus A prime times B.
Bx squared
Minus 2x.
plus 2x. So this is gonna be bx.
So it's easier if you write it off to the side so that you know what you're doing when you multiply together. So your A is 7x minus 12. And then here again you apply the power rule.
Mm-hmm.
And this just becomes 7. And this 12 goes away because it's a constant.
Right.
And you have B.
B is gonna be 6x. 6x. No, minus 2.
Yep.
Right, 6x minus 2. So now I'm gonna do,
And now you're going to multiply
now
all
I'm
that.
gonna do
Well,
A, I'm gonna do this. Am I gonna do this? 7x minus 12.
mhm.
Wait a second, sorry. Sorry. A is 7 times 7x minus 12. So there's supposed to be a plus sign between those two things up there. Sorry, in the product rule. Yeah, and I got it. I got a plus
Not
sign.
in the
Yeah.
original.
No, I know. I was looking up at the thing. I couldn't read my, I wrote it really lightly. It's okay, I got it. Plus, now, A prime is, shoot. The power rule. Okay, so the power rule, ooh, with a
X.
negative one. Okay, so let me see here. Another example, negative 12x to the 10th. Okay, so it should be negative 120x to the 9th.
Yep.
Hmm?
Okay.
Yeah!
The rule is you take term A times it by the problem of term B plus the first term times the problem of the B term.
Right, that was the
So if you
third
had,
one that we
like-
learned properly, right?
So if you had like 3x plus 1, x plus 2.
And I remember,
A
yeah.
plus B.
And then you did the type where you go when A and B, you had little
A
brackets.
equals A prime equals B equals B prime equals. It's like that.
I love that way. I thought that was very helpful.
Yeah. And then the constant rule is like if you had y equals 7 or something like that, that always equals 7. 7. That always equals 0.
Zero.
Yeah.
So that, I had to know that, for instance, when I did that,
The
when I did that,
Yeah, when
yes,
you're
the
doing
sum
like
and
this one,
difference, I
if
had
there
to
was
know
just a
that.
plus 7, it would be 0.
Right.
And then constant multiple is if you had like that,
What I
and you
don't
have
like. Rewrite the problem.
Yeah.
You start off by rewriting the problem.
So then that would be x, because there's a 1 here, that's x to the 1/3.
Right.
And then you're going to use the power rule. Oh, I didn't write the power rule. Okay. Well, this is the power rule here. So when you do the power rule, you say that's 1/3 x, and then you say 1/3 minus 1, which is
And I
negative
can't have a
2.
negative exponent, so I have to put that in there, so it'd be the
Yeah.
cube root
So
of,
then you would write 1/3
X
and
squared.
take that
Mhm.
down.
with a cube,
With the cube.
cube root.
Oh, okay.
I got this, girl.
And then sum and difference is if you had like,
You can erase that amounts, certainly. Just not my, tally sheet, because I haven't written that down. No, they're just wonderful teachers.
if you had like 8x squared plus 6x plus 2 or something, That was 16x plus 6.
16x1 plus 6 plus 0.
Yeah, so you don't have to write the plus 0. And then it'd be the same thing if it was a minus sign there. You just have a.
Sum or
Minus
difference,
yeah.
exactly.
You think you're ready?
I think I'm ready.
I know it's a lot.
I think it's good.